right, really focus in on this one. This one's a little tricky. It's not necessarily that it's a whole lot of new math here, but dividing complex numbers really doesn't even exist. We don't actually even divide them. Instead, we're going to multiply the complex conjugate of the denominator. We're going to multiply by the complex conjugate of the denominator. So we have to remember how to do some foiling and distribution, and this, again, this fact that I squared equals -1, so we don't want any I squares in our answer. And really one of the big ideas here is just the fact that there's I in the denominator. Okay, well, I, remember, equals the square root of -1. So if we ever see an I in the denominator, that's an unreduced issue. I mean, that's an issue with reducing, right? We know that we can't have a square root in the denominator. We can't have the square root of 3 in the denominator. So you also can't have I down there, which is the square root of -1. Okay, even worse, it's got a negative under the root. So there's a couple issues, and that's really what we're going to try to clean up. We're going to try to get rid of the I from the denominator. Okay, we do that by multiplying by the complex conjugate, and then foiling and doing all the I squared stuff. Okay, so here's what it's going to look like. Instead of dividing, instead of like going north south like this, what we're going to do is we're going to multiply. And we're going to multiply by the number 1, so we don't change what we started with. We're really just kind of simplifying this. And here's the conjugate of the denominator. So the denominator says 1 minus 2i. The conjugate is just going to be 1 plus 2i. So that's really not that tricky to find out at all. You just switch the sign in front of that imaginary term, and you should be good to go. And we turn this into kind of a difference of two squares pattern, where we get the outsides and insides to cancel, and everything will be good to go. Now, we can't just do it to the bottom. We have to also do it to the top. Okay. So here we go. If we want to simplify this, remember, we have to FOIL the top out, right? So we're going to go ahead and FOIL the top. So we take 5 times 1, we get 5. And then we're going to take the 5 times the 2i, we get plus 10i. And then we'll take the 3i times the 1, and we get plus 3i's. Okay. And then we take the 3i times the 2i, and we get plus 6i squared. Okay, all over. Let's do the same thing to the bottom. We'll distribute the 1 to the 1, we get 1. Distribute the 1 to the 2i, we get plus 2i. Okay, and then distribute the negative 2i to the 1. And then we take the negative 2i to the positive 2i. We get minus 4i squared. Okay, so we did all of our distribution and foiling. Now, clean things up. So on the top here, remember, we're going to have a 5. The 2i terms can be added up. So we got 10i and 3i make 13i. And then the 6i squared, if you remember that I squared is actually equal to -1, that's really positive 6 times -1, which turns into -6. Okay. All over. Now look what happens in the bottom. And this is what we need to have happen in the bottom. We're going to get 1. Okay. But the positive 2i and the negative 2i just cancel each other out, and they're gone. And that's our goal, is to get rid of the I in the denominator. So the next step here then is just to go minus 4. Remember, the I squared here is also equal to -1, and that's going to take out the I squared term. So now if you look at the bottom, there's just constants down there, and that's what we're looking to get to. So let's clean this up one more time. 5 minus 6 is -1. Those are both just constant terms. We can combine those. And then plus the 13i, that's on top. I's are perfectly fine in the numerator. We just can't have them in the denominator. And the bottom here, now we have 1 minus -4, so it's really going to turn into 1 plus 4, which gives me 5. Okay. Now to write this answer out correctly, we would want to put this into real plus or minus imaginary parts. They need to be separate. So we just divide both of these by 5, and we get -1/5 plus 13i over 5, or another way to write that would just be 13/5 I, and there is the correct answer. All right, let's take a look at the number 2 here. All right, here we go. Let's check it out. We get 2 minus 7i all over 1 plus I. Again, we got to identify that complex conjugate again of the denominator. So the complex conjugate here is going to be 1 minus I, and that's all over 1 minus I. So again, this in parentheses here, this actually just equals 1. So we still have the same thing we started with. But now we got to do some foiling here. So we'll take the 2 times 1, we'll get 2. Take the 2 times the negative I, we get -2i. Take the negative 7i times 1 is -7i. And then take the negative 7i times negative I, it's going to be positive 7i squared. All right, all over. Distribute the bottom. 1 times 1 is 1. 1 times negative I is negative I. This should cancel out my i's now. Watch this. I times 1 is plus I. We should see that happen every single time. If we use the right conjugate, this is what's going to happen. And then I times negative I is negative I squared. Okay, let's clean this up. In the top, we know that the I squared here is really -1. Okay, -1 times 7 is -7. So we have -7 sitting here, positive 2 here. That's going to give me a -5. Okay, combine the 2 I terms here. -2i minus 7i is -9i. All over. Now again, the i's have to cancel. If we use the right conjugate and we multiply correctly, the i's will cancel on the bottom. This is really just 1 minus the I squared, which is negative 1 also. We're going to make sure we do that little substitution right there. And then we end up seeing we get negative 5 minus 9 i's all over 2. Okay. Split it up so it looks like a complex number, and we get negative 5 halves minus 9 halves I. Okay, that I can be up on top too. Okay. The calculator here can also handle these for us, just to give you a quick idea here of what this looks like on the calculator. If we divide them, you just got to make sure you put them in parentheses, 2 minus 7i. Okay, divide that by 1 plus I. As long as the top and bottom are in parentheses, we should be good to go. The calculator is going to spit out a decimal answer for you, which nicely, our math enter will also turn that back into a fraction. So we get the negative 5 halves minus 9 halves I. There's your answer. We're good.